expect to happen? Joss, what do we expect to happen? We drop something from rest. Yeah, it's going to accelerate. Yay! And why is going to accelerate? Nice. It's early. It's Monday morning. Gravity! Yay! Now, if I include air resistance, now, by the way, gravity, for what our purposes are here on Earth, is 9.8 meters per second squared. If I change this, okay, if I change this to include air resistance, because this free fall example is no air resistance, Jack, what do you think is going to be different about the acceleration? Yes, it'll be less. So does the acceleration change? Yes, it'll be less. Which means the acceleration will not equal 9.8. The acceleration will be less than 9.8.
Wouldn't it just be constant after a certain point?
We'll get there, but yes. So the acceleration is going to be less than 9.8. Okay, so number 3, we're going to do this one quickly because we talked about this with the lab. So if you look at the front page on your lab, so we said, what is air resistance? We said it's a force that resists motion through a fluid of some sort. Generally, we think of free fall, but it's basically a resistance. Yep. So resistance force of an object through air. Technically, it's any fluid. And what causes it is friction of air particles rubbing on the object. Okay, and you all know this, right? If you run, the faster you run, the more you feel the air blowing on you, okay? And that's a physical thing you can feel. As the wind blows harder, you feel it on you more. So therefore, the more the objects rub against your skin, the more friction there's going to be. Okay. Which brings us to number 4. And this one is super important for 2 reasons. One is it's important to know what affects air resistance. But even more so than what affects air resistance, this is one that you are not going to expect until you think about it, and then it'll make some sense. What affects air resistance? So the thing that affects air resistance more than anything else, and I think it talks about here, yeah. What affects it more than anything else is velocity. Air resistance is not affected by size. It's not affected by mass. It's not affected by the stuff you're going through. Air resistance is affected predominantly by the velocity of the object. Predominantly. And a little bit, the substance it's going through. But it's mostly this one.
Could you define velocity real quick?
Yeah. So velocity is the speed in the direction it's traveling with. Yeah. So the thing that affects the air resistance is how fast it's going. And that might seem weird, because you might say to yourself, well, isn't the air resistance affecting how fast it goes? No. So the air resistance does not affect how fast it goes. How fast it goes affects the air resistance. I know that sounds convoluted, but it's going to make sense in a second. So velocity is the thing that matters. Okay? Okay. So, on the back page here, see, look, we're cooking. Why does speed have such a big effect on drag force? Why is air resistance affected by speed so much? So the reason is, as you build speed, you build friction. The faster you go, the more and 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 the more it starts rubbing on the air. And so the faster you go, the more friction you're going to have, and that's going to increase your increase the effect that it has on air resistance. So the faster you go, the more air resistance you build. Which brings us to 6. So terminal velocity and its effects. So terminal velocity is when the drag force, the air resistance force, when that equals gravity. When those things equal to each other, that's called the terminal velocity. And Joss mentioned it earlier. This is going to happen, and there will be an acceleration of 0. At this point, it'll stop speeding up. And for this, the things that affect this are exactly what we did in the lab. So size / shape / surface area / aerodynamics.
Can you break terminal velocity? Like go faster?
You can change it, but you can never not have one, if that makes sense. Size, shape, mass, and density of fluid, what you're going through. These 3 things affect the terminal velocity. So the terminal velocity is how fast it can go before it balances air resistance and gravity. So why does terminal velocity, why does an object reach terminal velocity instead of increasing velocity forever? And that's because when, again, kind of what we mentioned here, when the force of drag equals the force of gravity, you have an acceleration of 0. Okay, let's look at this video here. So I'm going to show you